Hi guys, and welcome back to grade 11 trigonometry. We are almost at the end. Our journey is about to end on this long section. It has quite been a long one. We want to now get into one of the tricky sections, the one of proving identities. Okay, so I just want to remind you, okay, identities. Just want to remind you of the two important identities that you are going to use. Actually, these are called fundamental identities. They're very fundamental, okay, identities. I'll just say IDS there. One is the quotient identity. We have proved this previously. You can just check the video that says identities. And the second one is the square identity. We have also proved this, sine squared theta plus, okay, plus cos squared theta is equal to 1. Now, from this identity comes a number of identities. First, if I make sine squared theta the subject of the formula, I get the fact that sine squared theta is equal to 1 minus cos squared theta. But if you look at 1 minus cos squared theta, is a difference of two squares or perfect squares. So I can write this as 1 minus cos theta into 1 plus cos theta. Also, if I make cos squared theta the subject of the formula, then it is 1 minus sine squared theta, which is also a difference of two squares, and I can factorize this into 1 minus sine theta into 1 plus sine theta. Yes. Now, guys, you need to recognize this, okay? Whenever you find yourself trying to prove an identity, if you see something like this, then know you can convert it into that or that. The same thing down here applies. You will see this square identity in different forms. So what I'm showing you is the possible forms in which the square identity can appear. All right. So let's take an example and see what we can do. Right. I'm gonna take this one here. We are required to prove, RTP means required to prove that sine x over 1 plus cos x, no, not equal to, but plus, okay, cos x over sine x is equal to 1 over sine x. Now, whenever you see something like this, there are three ways in which we can prove this. First method, I can say, well, let me just change the color of my pen. One, I can say right-hand side equal to left-hand side. Actually, I shouldn't. Okay, it's fine. Anyway, let me just continue. Secondly, I can say, well, I can prove left-hand side is equal to right-hand side. So what this means here, I can move from right to left, okay? Number two, I can move from left to right, or I can simplify left and also simplify right. And then where I see that they are giving me the same thing, I can stop right there. So the third method is just really when you have tried 1 and 2, you have tried moving from right to left, you're not winning, you're getting complicated stuff, you are even confused. You have tried maybe left to right, the same thing happens. Then resort to the last method, okay, where you simplify the left side and you also simplify the right side a bit and see if they can both simplify to 1 and the same thing. Maybe the third step or the fourth step, the second step. I know, but there should be a step where you see that these things are now giving me exactly the same thing. And that's where you stop. That will be your stopping point. So these are the three possible ways that we can use. So now looking at this problem, if you ask me, say, which method would you use? I'm gonna go for two, where I show that the left-hand side is equal to the right-hand side. And why do I pick the left-hand side in this case? Because the left-hand side is less simplified than the right-hand side. The right-hand side is actually more simplified. Is one term. What am I gonna do with one term? How am I going to break it down? There are different options to break it down, but which of those many options am I going to choose? So to save time, I'm just going to take the left side because I can see I've got two terms and I'm adding those fractions so I can work with a common denominator. So that is the motivation for me to pick the left side. Okay, so let's get started. Let's see here. So I'm going to write left side as sine x over 1 plus cos x plus cos x over sine x. And I'm going to take my common denominator here, which will be sine x into 1 plus cos x, okay? Of course, I could have made that tan, but what am I really doing with tan? Because my objective is to have sine x on the denominator. So at least I have a sine x, and I know I gotta have some cancellation. I bet I have some cancelling or division going on so that this 1 plus cos x goes away. So now let's see. Algebraic fractions, grade 10. How did you solve this? The LCD, what is missing here is sine x. So I'm gonna multiply sine x by sine x, okay? So simplifying this fraction, I'm gonna get that. Same thing here, what is missing? So I'm gonna have cos x into 1 plus cos x, okay? That's what I have. Then the numerator simplifies as follows. Sine squared x, okay? So that's what I have there. Let's see, sine squared x, okay? Plus cos x, okay, plus cos squared x. Okay, now this is all over sine x into 1 plus cos x. Now guys, I'm gonna create a little mess here for you, and I am going to continue this thing here at the top. So I'm going to continue it here. I mean, you can always rewind and go back and forth on your thing there, on your phone screen. So I am sorry for rubbing this out. So I'm going to continue up here, and I already see a solution. Now check. Okay, let me start by writing this stuff. Okay, so I have sine squared x plus cos x plus cos squared x. And this is all over sine x into 1 plus cos x. So the interesting thing is that now, what did I tell you about the square identity? It's going to appear in different forms. Check. Here is the square identity. I have sine squared x plus cos squared x. And this is what? It's 1. So that means I have in the numerator 1 plus cos x. But guess what? That is something that I have in the denominator. Okay, so this thing will just divide that, and I'm left with 1 over sine x, which is my right-hand side. And so I am done with the proof. That easy? Yes, it's not that I'm making it sound easy or look easy. I am just using the logic of what? Problem solving in this case. So I hope you remember what I did here. I looked at the left side and the right side. Which one here is more complicated? and it was the left side. So I can see, I could see that, okay, I can actually simplify the left side and make it look like the right side. And that's all it had to take. Okay, in the next video, I will roll out some other examples. I think I'll do 2 more examples and then challenge you guys to try a few identities before we move into general solutions. Until then, keep well.